We will now look at some additional examples for truth tables. Our first example says, determine the truth value for each simple statement. Then use these truth values to determine the truth value of the compound statement. Our problem says Paris is in England, or London is in France, and Berlin is in Germany. So we have three simple statements. Let's look at each one separately. Paris is in England. We need to determine whether that is true or false. We know that Paris is in France, not England, so this statement is false. Our second statement says London is in France. Again, we know that this is false because London is in England. Our third statement says Berlin is in Germany, and we know that this one is true. Now, we have determined the truth value for each simple statement. Let's now determine the truth value for the compound statement. So looking at the first two events, and notice that we have the comma here, so we know that those two will go together. We have false. The or gives us the V symbol in between. And we have false for the second statement. These two are in parentheses because they are separated with the comma from the third event. The third event says that Berlin is in Germany, which we already know to be true, and we have an and. So we'll use the symbol for and we have a true. Now we have our compound event written. Let's determine whether this is true or false. We know that false or false is going to give us a false outcome. So we've now taken care of what's in parentheses. False and true gives us a false outcome. And so we know that the truth value of the compound statement is false. Our next example says, let P be that Abby owns a convertible, and let Q be that Claire owns a Volvo. We want to construct a truth table for the compound statement and indicate under what conditions the compound statement is true. Our statement says that Abby does not own a convertible, but Claire owns a Volvo. So let's look at this with each piece in mind. First of all, Abby does not own a convertible. We know that P is the fact that Abby does own a convertible. So the negation of P would be saying that Abby does not own a convertible. Recall that the but is another way of talking about and. So we're going to use our symbol for and. And then we have Claire owns a Volvo, which we know is Q. So what we are trying to find is the negation of P and Q. And so let's go ahead and set up a truth table for the negation of P and Q. All right, so I'm going to make my table, and I'm going to make a column for the P and a column for the Q. We know that we'll have 4 outcomes. For the P, we can have T T, F, and F. And for the Q, we'll alternate between true and false. Now we'll write down the statement that we're looking to find. So we have a negation of P and Q. And we'll fill in what we know. Right? So I can go ahead and copy down the P column. And I can copy the Q column. The first thing I want to work on now is the negation of P. So I'm going to look here at the P values and I'm going to write down the opposite. So we start with the true, the negation would be false. We have a true on the next row, the negation would be false. We have a false, the negation would be true. We have another false, the negation would be true. So now we are going to look at this column and this column. And we're going to do an and. So if we have a false and a true, we know that that is equal to a false. If we have a false and a false, that is also false. If we have a true and a true, that will be true. If we have a true and a false, that will be false. And so if we look at this, we see that the only way that this is true is in case 3. Let's look at one final example. Let P be that the house is owned by an engineer. Let Q be that the heat is solar generated. And let R be that the car is run by electric power. Construct a truth table for the compound statement and indicate under what conditions the compound statement is true. And our statement says the house is owned by an engineer. So we know that that's event P. And, I'll use my symbol for and, the heat is solar powered. So that's going to be Q. And then I come to my comma. So the comma separates the part in parentheses from the part that is not in parentheses. So we now have the house is owned by an engineer and the heat is solar powered. And then we have an or, which is going to come in outside of the parentheses, or the car is run by electric power. And so we are trying to find in parentheses P and Q, and then outside of the parentheses, or R. And so we're going to set up a truth table for this compound statement. Now again, since we have 3 events, P, Q, and R, we know that our truth table is going to have 8 different cases. So I'm going to begin by making a column for P, a column for Q, and a column for R. And we're going to list out those 8 cases. Remember that under the P column, you will have 4 trues and 4 falses. On the second column, you will have 2 true, 2 false, and you will alternate. And for the last row, you will alternate, or the last column, you will alternate true, false, all the way down. So we'll now extend the table and we'll write down what we're trying to find. P and Q or R. And we'll go through, and first of all, we'll copy the P column, the Q column, and the R column. So let me do that first. Now, once that's complete, then we'll work inside the parenthesis first. So we want to look at P and Q. So we know that if P is true and Q is true, then the AND is also true. If P is true and Q is false, the AND is false. If P is false and Q is true, the AND is false. And if both the P and the Q are false, then the AND is also false. So we're now going to take the answer to the part in parentheses, and we're going to combine it with the R using an OR in between. So if we have a true or a true, then we know that the final result will be true. If we have a true or a false, the final result will be true. A false and a true, we have a true there. A false and a false produce a false. A false or a true produces a true. A false or a false produces a false. A false or a true produces a true. And a false or a false produces a false. And so the answer that we're looking for is what we have here in red.